Hello friends, my name is Almas and today we are going to talk about Java Collections Framework. Let's quickly look at the agenda for today's discussion. We will talk about collections framework from a 30 feet overview. We will look at what collections mean, and we will give you a gist of what are the different classes and the interfaces that are involved in collections framework. We will also talk about generics, what role generics play in with respect to Java Collections Framework, and why do we need generics. Then we will touch base upon iterators, what iterators are, why do we need iterators, and how helpful they are with respect to Collections Framework. Then we will touch base upon the ordering, object ordering within the collections, whether it's necessary, why we need it, what do we need for every collections or few collections. So we will talk about that. We will talk about collections interfaces. We will give you the gist of all the implementations that we have for the collections, but we will specifically talk about a few known APIs, known data structures uh, in um, brief. And then we will talk about the utility classes. What are the utility APIs, static APIs that has been exposed to us from the Java Collections Framework. Let's talk about the collections. What collections means? Collections is nothing but a way of organizing the data so that you can retrieve the data, you can delete the data, you can add the data. So collections assume that you have a container or a black box or a box. Yeah, you want to insert balls into that box. You can insert a ball with the radius 10 centimeters. You can insert a ball with a weight 100 pounds. You can insert a ball with red color, blue color, and so on. And finally, you can perform various operations like let's say filtering, where you can say that I want ball with weight greater than 100 pounds, or I want all the balls which are red in color, and so on and so forth. So that's what a collection is. The important package for in Java Collections Framework is java.util, where all the interfaces and the classes reside for Java Collections Framework. Now let's talk about the benefits of Collections Framework. L- So these collections are already been provided, and it's written by the Java experts or the algorithm experts. They have already benchmarked these APIs. They have profiled these data structures so to make it more efficient. So one would say that I know the how a list is being implemented. For example, I could implement that well in Java. Very well said. Yes, you can. But why to reinvent the wheel when already you have a implementation, unless until you have a specific use case, or you are trying to over optimize your code, or you are trying to think about making use of primitives instead of the objects, and so on and so forth, then it makes sense for you to write your own APIs. But if not, then let's make use of the data structures that are being provided by the collections framework, where you get uniformity. The APIs are consistent. It's been fine-tuned, and it's already all the powerful data structures being present. So I would recommend to you to use these collections until you have a specific use case. So here is the 30 feet overview of the collections framework, different classes and the interfaces that are present in Java. The rectangles that you see in with the dotted lines are the interfaces, while the rectangles with the concrete lines are the implementations. As can be seen, right? The collections collection is the top level interface, and there are two other interfaces which are implementing the collection interface, that is the list and the set. Now, what is the list? List is nothing but you can consider it as a an sequence of objects where you can insert the elements. You can maintain the sequence where you can insert in the middle or at the both extreme ends. You can get the elements from the middle, from extreme ends, and so on and so forth. So it's like list of numbers where you're inserting 1 2 1 2 1 2 or 1 2 3 4 5 6 till 100 or something of that sort, while a set is analogous to mathematical term set, which doesn't allow you duplicates. It's like you are not going to have two elements or two equal elements where you can say, hey, I have a set of 100 numbers, now I'm trying to insert one again into it. So it won't allow you duplicate entries into your set. Multiple implementations of the list and the set that we are going to talk about when we will cover list and the set. On the other hand, map is a key value pair similar to telephone directory, where you have a number associated with the owner of that particular telephone number. So in this case, string telephone number is represented by a string, which is a key, and the owner name, again, it's a string, which is the value in this case. So if I want to do a lookup on a telephone number, who is the owner for that particular telephone number, I can give the key to this map data structure, and I will get the value that is the owner of that owner of that telephone number. Remember that it doesn't extend the collection interface, but it does produces the collection, and it does produces the iterator. What does that mean is like it's going to give you another data structure like a set, the entry set, and you will be able to iterate over the collection as well. Again, there are multiple implementations. We will cover give the gist of all the implementations, and we'll cover few of them when we'll talk about map. We talked briefly about the object ordering that we are going to cover in the next slide, and these are the interfaces that we will talk about mostly. And we do talked about that we are going to cover utilities. So these are the utility classes which are providing static APIs. We are going to cover that in our next upcoming slides. Let's quickly talk about generics. What are generics? Let's assume that you have a data structure or a collection which just works with the integer, that is the numbers. Let's assume that we have a new requirement now, and we have to deal with the float or a double value, or more complex object like a person, which is having their height, weight, ID, name, and so on and so forth. How are we going to do that? A data structure which is already implemented for integers. One would say, I would use that data structures, one per data type. Maybe I will use one for float. I will copy paste it for to accommodate double. I would copy paste it to handle any objects that is person. Well, you can do that, but it comes at a cost where you have to duplicate things, you have to maintain it, you have to test it. If a bug arises in one of the implementations, you have to make the changes at the several places. So that's where generics comes into picture. A data structure is defined as a template, right, which takes object of type T, and it will act on that T. So that T you're going to specify when you're writing the code. Now we will look at that, how we write it, how we specify what are the different objects that one can expect within the container. Like ball was one of them. Generics helps in at the runtime, while in the compile time it will give you an error if you are making use of a list of a ball and you are trying to insert, let's say, integer value to it. So at compile time you will get an error. Let's take a quick look on uh, the entry interface in java.util.map. So entry, as we know that map has a key and a value, entry is defined, it takes a key of type k while value of type v. So it can be any to any object. Key can be anything, v can be any object. So I can define my telephone directory k as a string and v as again a string, or can be a complex object like person, having the ID, having the name, having the address, who owns that telephone number. So in this way I can say get value. When I'm going to say get value, I'm going to get a person. I'm going to set a value which is going to set a value person against that key. I can say get key, where I can get key associated, and so on and so forth. Let's quickly talk about the iterators. What are the iterators? Iterators are nothing but an easy way to iterate over the collections, like the balls that we had. How are we going to iterate over each and every ball? How are we going to filter out the balls with red color? That's where iterators are helpful. So iterators mainly resides, as we know, is in java.util, and there are two types of iterators: the failsafe and the failfast. A failsafe iterator is that is working on the copy of the collection. So what happens is you add the elements, remove the elements while iterating, or another thread is adding and removing to the same collections. It won't impact your iteration. You won't get any exception. It will be handling that exception, because you are going to work on a copy of the data that is there in the data structure, as opposed to actually working on the data structure. While on the fail fast side, you're actually working on the data structure. Hence you will find that you will get a concurrent modification exception when you go into that situation where maybe another thread is actually modifying the data within the data structure. By data, what I mean by that is adding or removing the elements while one thread is already reading the data, or the iterator is working through it. There are three important methods in an iterator: has next, next, and a remove method. Let's assume that we are on this node, node number 2, and you have a node 3 as well. So what has next is going to do is it's going to check whether node 3 exists. It does, so it will return you true. Let's assume that you are on the node 5 and you're checking has next. It doesn't have a next node, hence it will return false. When you do a next, you are going to grab the node 3 value, whatever the value is going to be. Like a list of balls, you're going to get ball number 3. While you can remove at the same time the element that you're iterating, that the pointer is pointing to. At the moment we are on the node 3. If I want to remove the element, I can remove that, which will leave my data structure with 4 elements. Let's quickly look at the example, how we can iterate in a loop. So for the simplicity, I have a same method, and I have used the collections as an argument, and I have used the follow-up, where what I'm doing is a new way of creating an iterator. I'm checking every time whether iterator has next. If it has a next, I'm going to print that next element. While on the other hand, I'm using a for each loop, where I'm iterating over the numbers, the collections, and I'm printing that item. While in Java 8, I'm using for each and I'm printing that number, using for each. Let's look at what object ordering means. If you have a list of numbers, you want to or a list of person, you want to arrange the persons based on their height. uh, Maybe that is kind of a natural ordering for the persons in navy, for example, right? Starting from lower to higher, i.e. the increasing order. That's where a comparable interface is going to be used, like we already have in JDK with respect to wrapper classes or string class or a date class, where the wrapper classes, the integer or the numbers basically, the double, the float, and so on, are based on the lower to higher, that is the increasing order. Similarly, string is based on lexicographically, from increasing to increasing order. Date is chronological. That's the natural ordering. Well, if you want to change that, if you're not happy with the whatever it is doing, like for example in the person example, I don't want it to be by height, I want it to be weight, and I don't want a natural ordering. Well, in that case, I could use the comparator interface. There are other uses where I can use the comparator. I can use it when the natural ordering is not being provided. Like for example, if a person is coming without a natural ordering, it's up to me how I want to sort these navy persons. That's where a comparator is helpful. Let's quickly look at the example to explore more and know more about these two interfaces. Let's say on the left hand side we have an implementation of a point which is implementing the comparable interface for that point class. It has a 2D point, it has x and a y coordinate, and it compares. The natural ordering says that you have to sort on the basis of an x-axis. Here, on the other hand, I have created three different points, and I have sorted that by the natural ordering, and I have used the arrays class, that's a utility class that we are going to look at, and a sort method of that utility class. Similarly, I have used a toString which is going to print my array in human readable format, something of this sort. As can be seen, it's sorted very well by the natural ordering, that is by the x-axis. Now I have a requirement where I have to sort these points by the y-axis. One would say, there may be a different implementation that I might need, and I have to maybe repeat whatever is there. But Java is clever enough, it knows about our requirement, and hence it provided us the comparator interface. That's where I'm going to provide, using Java 8 syntax, I'm going to provide the comparator where I'm going to compare by the y-axis. And then in the sort method again, which is a utility, I'm going to pass that comparator. So now Java knows that, the sort method knows that I have to use this comparator and I don't have to use the natural ordering. Hence, when you will print the points, it will sort, or it will order the points by the y-axis. So as you can see, y equal to 1, 2, and 3. That's in a nutshell what object ordering is and what are the different interfaces that supports the ordering. Okay, let's talk about the list. As you can see, the hierarchy of the list. You have a collection at the top which produces the iterator list. As we talked about, it's producing the list iterator. Lists are very helpful when you want a sequential access to the elements. It allows you to duplicate elements as well that needs to be added into the list. So it can be of two types: a random one with a random access, the other one which is, again, it's going to be strictly from one or the other end, rather than the random access. You might have heard about the queues, which is what you see here. It's accessing from one end while removing from the other end. It follows strictly first in first out order. The element which is inserted first is going to be out first. While if you look at the stack, it follows a LIFO, that is a last in first out. The element which was inserted latest is going to be the first one to be removed. Similarly, you have a queue which is a parent class for the deck, which is a double-ended queue, which has 2 pointers, one on the left hand side, one on the right hand side. Each node, or each element, will have two neighbors pointers, pointing to the neighbors. So a random access list is just going to access it will give you the access to the elements in the random order as well, based on the indices. The one that construct that provides us the random access is an array. How different it is from an array. Assume that you have an array of size 5, and now you filled in array, numbers from 1 to 5. Now you want to add a sixth element. What are we going to do? In this case, we will have to recreate the array, copy all the elements, and then add the sixth element. While on the other hand, the list data structures are the self-growable array. What it means is, like, if you add the sixth element, it is going to auto expand or auto shrink based on the on how we are going to use that list. So array list is one of the implementation which is backed by an array. Similarly, copy on write array list and a vector is implemented or backed by an array, while a deck is a dynamic dynamic node based data structure. It has two implementations, a linked list and array based deck, while a priority queue, we will talk about it in the next slide. Let's talk about the gist of the different implementations. The array list, as we talked about, it's backed by an array. It has a low cost random access because of the array nature, and array has a locality of reference. High cost delete, because if you want to delete the middle element, you will have to shift every element in order to accommodate that space. Array that resizes if need be, as we talked about that example where we had to add the sixth element, which is out of the array capacity. A linked list basically backed by a double-ended queue. It allows you the sequential access, low cost insert and delete because you have a different pointers at the extreme end, but high cost random access because you will have to go node by node, each every traverse through nodes in order to and count it so that you know I want fifth element or sixth element at random. Array deck, similar to linked list but backed by an array. Priority queue basically is a heap where comparable or compare to comparable and a comparator is going to be used in order to decide whether I want a min heap or a max heap. Vector, thread safe list backed by an array. Stack is a LIFO, as we talked about. It's a thread safe as well. Synchronized list, a decorator over any list. It's again a utility that has been provided under collections, so we can create a thread safe list. Unmodifiable list, once we create unmodifiable list, the add and the remove operations are not allowed. While copy on write array list is a concurrent data structure which is a thread safe list backed by an array list, backed by an array. The difference between the concurrency and the multi-threaded or the synchronized list, stack or vector is, on a stack vector or a synchronized list, only one thread will act upon that data structure same instance at a time. That means you have made your program single threaded, while on the concurrent data structures, multiple threads can access the data structure and act upon the data structures based on the implementations. Yeah, it differs from one to the other. Let's quickly talk about the list API contract. The add remove contains size iterator, which is what we have seen, which we are going to look at through the examples. On the other hand, you can get and remove the elements from the index based on the index. And most recently in Java 8, you have a sort along with the comparator. How am I going to sort my list of items, list of objects? So here are the three different compartments. So the first one is to deal with the linked list and its API. The middle one, deliberately I have reuse the iterator from which is being used by both the implementations on third compartment is the array list. I've deliberately used the has next and the next. I could have simplified, which I have done it in the other examples in the slides that are coming in. So what I have done is I have added 5 elements into the list, and I'm checking whether my container contains China. Yes, it does, and hence it returns you true. Linked list, remember that it's taking into consideration only string items. If you try to add a number over here, a number one, digit one, it will throw you a compile time error. While if I want to get the index of China, that is 0, 1, remember that the array and the list, the index starts from 0. So China is standing at index 1. And remember, when you're printing it, you have a duplicate entry for India, and that is perfectly valid for a list. While you can try to remove an object from the collection, here I'm giving remove USA from my collections, and it removed. I can say of a first, add at the first location, or add at the remove location, at the last location, which is where if I iterate it, I have the first element as a Poland and the last element as Austria. Similarly, I can poll first, poll last, which is coming from your deck. That is, I want to remove the first element and the last element of the list, that is India and Austria, Poland and Austria. With that, I'm left with um, the China, India. While I can say peak first. What is the first element? It's China. What is the what is the last element? I can say Australia. On the other hand, in the array list, I did the same thing and I got the same output. I can use contains and index of. Here I'm removing an element by index, so 0, which is quick in this case. Although I could have used in the linked list, which is not that efficient, and it has the efficiency or the bit or the time complexity for it is going to be O of n, while here it's going to be O of 1 to remove an element by index. So 0th index India is there, so I've removed India. While I can remove from object as well, where it's going to make use of equals method and check whether USA exists. Yes, it does. So it will remove the entry of USA from the list. While I could replace the elements at index 0 with Poland. Index 0 contains China, so I'm going to replace it with Poland. While I can get element at index 2. Remember, it's 0, 1, and 2. So Australia is the one that is residing at index 2. Country.sort collection.reverse order. So it's at the moment Poland, India, Australia. I want to sort them lexicographically in the reverse order. So it will be Poland first, then India, and then Australia. Let's look at the set interface and the implementations. So again, the collection is the top level interface which produces the iterator, while we have different implementations which we are going to look in the next slide. But in short, we are going to cover the marked implementations, the hash set and the tree set. So hash set is backed by a hash map. What is hash map? We are going to look at when we are going to explore map, but it's a key value pair basically, which uses hashing technique to store or retrieve data. So the entry that we are going to insert into a hash set has to implement a hash code and the equals method, without which we may or may not get the elements from the set. Because it makes use of hashing technique to identify the location at which I want to insert that element, and if there are collisions, I want to find the elements. I will use the equals method to find out the elements, whether for example US exists, US exists, US exists. A linked list which extends the hash set while maintaining the order in which the elements are inserted. Due to the hashing technique, right, in the hash set, it is not guaranteed that you are going to get the elements in the order which you inserted. Like for example, if you inserted 1 2 3, you may get 3 2 1. While in the linked hash set, you are guaranteed to get 1 2 and 3 when you are going to iterate over that collection. Tree map, which is backed by a tree map, a tree set is backed by a tree map, which makes use of a red black binary search tree. What is binary search tree? Where you have an element, let's say for example number 10. All the elements that are going to be less than 10 are going to be on the left hand side of 10, while all the elements that are greater than 10 are going to be on the right hand side. So it creates a hierarchical tree. It's binary, so it has two children, one on the left hand side and one on the right hand side. Left side is always going to be the less than the while on the right hand side it's always going to be greater than its current value. Copy on write array set, that's a set which is backed by copy on write array list, which we saw in the previous slide. Concurrent skip list set, which is based out of a skip list, which allows us to concurrently uh, modify or act upon the data structure, and still treat as a set. Synchronized set, which is a decorator over any set implementation, so it's a thread safe set. Unmodifiable set, it's a decorator over any set implementations instance, so it's the best for a constant set. Once we created the unmodifiable set, we won't be able to allow or add or remove the elements from the set. It will throw unsupported operation exception if you try to do that. Let's quickly look at the API contract. We looked at the collections set is no different, while the navigable set, which extends from sorted set as well, has various methods which are helpful, like a subset, headset, first and the last element. Let's quickly look at the example to understand what are these methods. So I have three different compartments. One for the hash set, the other one for tree set, while the iterate method is using Java 8 for each method, which is going to iterate and print the set elements. So hash set, which accepts string, where I have India repeating twice, and I have 5 entries that I have added into the countries. If you look at the countries.size, you're going to get 4 because it doesn't allow you duplicates. So you have just one instance of India. While you can check whether a particular country exists into that container, i.e. the hash set. Yes, whether it contains Austria? No, it doesn't. Whether it contains Australia? Yes, it does contain. Remember one thing, I have implemented I could have just given it a set of string, i.e. makes use of interface driven development rather than the actual implementation based implementation, but this is just for an illustration purpose. While tree set, which is based out of a binary search tree, red black binary search tree, I did the same thing. I'm printing the size of the countries, which is expected as per hash map as well. It's 4. I can predict the output of this tree set. It's based on natural ordering because I haven't provided any comparator for the tree set, in order to say which is my ordering what I want in a tree set. And similarly, I have used the contains method. I could use ceiling, which is nothing but an entry which is going to be equal to or greater than Japan. So Japan would, if it was there over here, this is the place where it would be. The entry that is next to Japan is going to be USA, while the entry which is going to be less than Japan immediate or equal to is going to be India. Since Japan is not there, we are not going to say Japan is going to be the output. The first element is Australia, the last element is going to be USA. Headset is going to be similar to whatever. If I would have got Hong Kong over here, this is the place where Hong Kong would be. If I would say headset, I would get Australia and China. If I would say tailset, all the that comes after India, USA is going to be the output when I'm going to say it's going to return you a set. Pole first and a pole last, which is deleting the first element, that is Australia, deleting the last element, USA, and hence we will be left with the China and India. That too is going to be in a natural sorted order as per whatever is defined in string. Let's look at a map which doesn't extend from the collections. It does produces the collections, it does produces the iterator, and it has a various implementation, out of which we are going to look at a hash map and a tree map. As we discussed, a map is nothing but a key value pair, where you have a key, maybe like a telephone dictionary or a dictionary, where you have a word and it has several meanings associated with it. So the key is going to be string, while there is a list of meaning associated with that particular word. Let's look at the gist of the implementations. So the hash map, which is nothing but where we looked at the hash set, which composes of a hash map, uses hashing technique for the key to store or retrieve data, which means that we should be having our key strong and has to be immutable, and it needs to implement the equals and the hash code contract of the object class. Um, then we have a linked hash map, which is going to extend from a hash map. It maintains the order in which we push the elements into the hash map, linked hash map. So if I inserted the elements like 1, 2, and 3 in a hash map, I may not guarantee that I will get 2, 3, and 1 out of that's the key, by the way. I may not guarantee that I may get the value as 2, 3, and 1. While if I use a linked hash map, which internally use a linked list, it I'm going to guarantee that you are going to get elements like the way you inserted your keys, like 1, 2, and 3, and associated value. A tree map makes use of a red black binary search tree, which we talked about, and this is tree set is composing of a tree map. Concurrent skip list map, we talked about the skip list, and this map you can use it to for concurrent get inputs. Concurrent hash map, basically two or more threads can access or act upon this hash map. A weak hash map, basically where the key is a weak key, whenever your strong key uh, is out of reach, right? Nobody is referencing to it. At that point in time, garbage collector may collect this entry and remove this entry from the hash map. This is very, very useful in case of where you need to be space optimized. Identity hash map, where you have where you similar to hash map, but it doesn't make use of equals and hash code. Instead, it is going to use reference checking for equality. Hash table, thread safe a map, synchronized map, decorator over any map implementations, unmodifiable map, which means that after that point in time, when you once you create the unmodifiable map, you won't be allowed to add or remove. Doing so may throw you an unsupported operation exception. Let's walk through the map API. As can be seen, you can put a key and a value, you're going to get back a value. You can get by a key a value, you can remove a key and you can get a value from a map. Size of a map, how many entries are there in the map. Key set, see that you are going to get a set out of it, because key has to be unique. It doesn't allow you to add multiple same key, same equal key. If we try to do that, it's going to replace the with the latest one, which we are going to see in the example. values, which is going to be collections of the objects that we have stored as a value. Navigable map, which extends the sorted map as well, which has various methods, which is similar to what we have seen in the set, which we are going to look in the next slide. Again, we have three compartments over here. The iterate, which is a common to both the left and the right implementation, which is a tree map and a hash map. So what we deliberately did is we tried to insert India with the Delhi as a capital and India New Delhi as the capital. So what map will do is it will take the recent value, that is the New Delhi, and it will ignore or remove this Delhi from the value. So if I try to do get on India, I'm going to get a New Delhi. Well, if I see the size of the array, it although I inserted 5 elements into it, 5 times I've used put. One was duplicate, so I see that its value is 4. The output of iteration is not specific because of the hashing technique being used for the string. Uh, I can say contains key, contains value, whether contains Austria somewhere, no. Contains key Australia, yes it does, so it will return you true. Contains value Beijing, yes it does. Similar to get what I've talked about, provided if I were to give I in a small case for India, it would generate a different hash code. While checking for the equality, it won't get India with I capital, which is already stored, and India with I being small. So I won't be able to compare as well. Hence, in that case, map will return me null, and I will end up printing null. If I want to avoid that null, in Java 8 you have a get order default. Either you get me the value or return me a default value. So Austria, since Austria is not present in the map, I will get a default value saying not found, which is again a string which is of the same type as a value. Coming back to tree map, again I did the same thing and I got a value of 4 when I queried for the size. Now when I'm iterating, I am sure that I'm going to get by the natural ordering because I haven't provided the comparator over here. So the natural comparing by the string, i.e. the key, is with starts with A and then reaches to Z. So Australia, the capital is Sydney. That's the first entry. Then China, then capital is Beijing. Um, and then you have India, New Delhi, USA, Washington. So ceiling key, Japan. If I were to have a Japan key, right, it would reside over here. So ceiling is the next element, next higher element or equal element. Since Japan is not there, I will take USA, and hence you will get a USA. Similarly, you have a floor key which is less than or equal to Japan. Since Japan is not there, I'm going to go back and say what is my next neighbor. So I have India. Similarly, I can get the first key, that is Australia, last key, that is USA. I can say head map, which is going to give me an instance of a map, which is going to be less than, i.e. if Hong Kong were to be there, it would be somewhere over here. So it will return me China and Australia. While if I were to say tail map, I would get India and USA. Similarly, I could poll for first entry and the last entry, that is deleting first entry, that is Australia, deleting last entry, which is USA, and my map will be left with the China and India. Let's look at the utilities API. There are two classes that I'm going to cover the next, the arrays and the collections. So we have seen a few APIs of the array class, so namely the sort, toString, to name few. While the collections also support the same API, similar APIs, the sort, in addition to that, it supports the min and max operations from the list, the minimum element and the maximum element. I can search on the list, I can reverse the list, I can shuffle the elements within the list, and I can query for getting me the reverse order comparator, that is the opposite order. If I have increasing order, I may ask for the decreasing order. Let's look at the example to clarify that. So I have an array of string where I have named a few countries over here. I can create a clone or a copy of that particular array. And I would say that I will need all the elements of that particular array. So I'm going to get a clone version of the countries. I can check for the equality of each and every element, that is two arrays being equal or not, and it will return me true or false. Similarly, I can give a human readable format by saying toString. I can sort the arrays based on the natural ordering because I haven't provided the comparator. So natural ordering of the string is lexicographically starting from increasing order. Parallel sort basically is it's a divide and conquer kind of a thing, which makes use of a fork and join, where input is divided and then it's merged into one. Um, then I can do a binary search on the countries. Remember that the binary search is going to work on the sorted array. So countries I have already sorted, as you can see over here. So I can search for a particular country. So I can say whether this country array has a Poland entry or not. Yes, I do have it. So what is the location at which it exists? So array starts from 0. So 0 is Austria, Germany 1, India 2, Poland is 3. So I will return the index of 3. While if the country doesn't exist, like Australia, I will return the index where it suits. So I can say it suits at the first location, i.e. the 0th location. So that's the binary search. While if I look at the collections, arrays has a beautiful method called asList, which is going to return me the list view of the data that I have provided. So it's a list, a string, which I'm going to get a list of string. I can sort. I can provide the collections. So natural ordering is string. I want it on the opposite side, that is the decreasing order, and hence I will get a decreasing order of my collection. I can do the reverse. I will reverse this particular collection so that Austria is the first entry, Germany is the second, India is the third, and so on. So I can get that. I can rotate the list to the right if it's a positive number, or to the left if it's a negative number. So I want to rotate by two positions, i.e. US and USSR should come to the first. So this is my rotated list. While if I want to rotate it to the left, again by two entries, I will get the sorted order, and I will push US and USSR. Not necessarily you need the sorted array for rotate operations. Collections.shuffle makes use of the randomness, random API. It's similar to like you have a deck of card and you are shuffling the card. So it will shuffle the entries within the objects within the list. And then you can find out the min and the max. As can be seen, the max is USSR when we sorted, and the minimum was Austria. So that's what we are going to get. Now giving the example of unmodifiable list, here at this point I'm creating the unmodifiable list, and if I try to add or remove the elements to the list, I will get unsupported operation exception, and you will see in the output that as expected has been returned. Okay, we are done. We are going to quickly recap what we learned today. So we talked about collections framework. We gave you 30 feet overview. We talked about various classes, relationship, interfaces, and the utilities, the ordering, object ordering interfaces that are there. We talked about the generics, what is the role in Java collections framework, how it helps. Then we covered iterator, what iterators are, and why is it important, and important methods of iterator. We did talked about failsafe and failfast in brief. Then we talked about object ordering, why do we need object ordering, and what are the interfaces, importance of the collections and the comparator interface. Then we talked about the core collection interfaces and briefly talked about the implementations, not for the all of them, which is out of scope of this particular video. We looked at the collection set list and map interfaces and a few APIs of the same, and we looked at the use case of each collections as well, when to use which interface. And finally, we looked at the utility classes, namely arrays and collections, and we looked at the APIs, static APIs that are being exposed by these utility classes. I hope you enjoyed this video. Feel free to let me know if you need anything specific to cover. Thanks for watching this video. Thank you.